My name is Siva. I am a developer advocate at JetBrains. So now I'm going to talk about building modular monoliths using Spring Modulith. So I think most of us heard about or work with monolithic applications and then microservices. Then now what is this new thing? Modulith, modular monolith. Are we got bored with microservices and coming up with some buzzwords, or is it something really that can help us to build better software? Let's find out. So I'm going to talk about what is a modular monolith and how we can build a modular monolith using a Spring Modulith framework. And then we can see how Spring Modulith helps us to build and then test each module independently. And also we can dynamically generate the documentation instead of writing as and then quickly it is getting out of date. You can directly generate based on your actual code so that there is no point it's going to go out of sync, right? So we are going to look at all of these things. So before that, let me ask you all, how many of you are currently working with monolithic applications, which are like, okay, so most of you. And how many of those applications are 10 plus, 15 plus years old code bases? More than 15. Okay, I think you are all happy. I can see that happiness in your faces. So how many of you are actually enjoying in your day-to-day work, working with these 15, 20 plus years old code bases? Not so much. And have you, any of you switched from working with monolithic applications to microservices? Really? Not so many. So, okay, I work with monolithic applications which are like 10, 15 plus years old in the beginning of my career. And then I started working with microservices thinking it's going to be better. But the experience is something like, have you ever felt like your current company is a crappy one, and then you find a new job, and then you join there, and then after a while you find, oh my God, my previous company is much better. Have you ever felt like that? So I had kind of a something similar experience. Like, I'm not saying microservices is bad. In fact, monoliths is not also bad. It's There are reasons why these applications get messy over the time. And when you switch to from monoliths to microservices, many people underestimate the effort it takes to run all these microservices working together, because most of the people focus on, okay, I don't have to worry about the entire system. I'll just work on this tiny microservice, not too much code base. I can quickly understand it. I can run it. But most of the people ignore the challenges in you need to make all these microservices working together. For that, again, all things come into picture. Like if you split your application into 100 microservices, 50 microservices, then one microservice might call another one. So when you involve this network latency, you need to take care of timeouts and all the network latency issues. And also you need to take care of monitoring, like okay, is circuit breakers and all observability. So it is like you think it is cute to work microservice, but somebody has to ensure that everything has to work together. So it is a lot of effort to successfully run microservices. So there are both challenges in both managing monolithic applications and microservices also. So this is where we need to find a balance. That's where modular monoliths come into picture. Like, we software developers are like a little bit passionate people. Like we want to work with cutting edge technologies and we want to play with something shiny and all. But we also need to think about, okay, is it really necessary for my application? Otherwise, we go one extreme, like, okay, monolith is bad. Let's all go to the microservices for thinking it is going to be super. But we need to find the balance. That's where I would say modular monolith fits. So what exactly is modular monolith? Okay, I think we all can correlate to this situation of working with monolithic application. You get a new use case to update a current feature, and you find it and then you update it and everything looks fine. But then later, 2 weeks later, you get a bug saying that 2 weeks ago you changed something and that is reflected somewhere else, unexpected place. We all been there, right? So similarly, when we go to microservices thing, this is inevitable. Like one day you get a bug report saying that, okay, when user click on that button, it says successful, but the other side, some other service has to reflect that it's not coming there. Who knows? I don't know. My service is working fine. Look at my database, it's correct, and nobody knows. So when you go into this knowledge sharing session, like what exactly happens when you click on that? First request come into this, and then it goes into that. There it will publish an event, and somebody consumed that, and it got failed. Nobody knows what happens after that. So you get into these challenges with microservices. So now this is where modular monoliths come into picture, where it tries to kind of find the balance, like best of both worlds. In modular monolithic architecture, you are going to still build one big application, and you are going to build all these subsystems as independent modules. But finally, you are going to build as a one big jar or whatever the technology you are using, and then deploy it. So is it software development 101? Like when we study software engineering in our college, what they usually say is when you want to build a system, first you need to break it down, build each piece itself, and then compose it and make it work together. That's nothing new. So then what is this modular monolith? Like it is same thing from the very beginning. It is how people suggest us to build the applications. So the problem is we know this is how we need to build the application, but you can read all the architectural styles and all the best practices and everything. But the moment you get a deadline, all these ideas and best practices goes away, and you are chasing to deploy your application on time, and then you start taking the shortcuts. Okay, let me skip this service layer, directly call that repository. I just need that data. That's how it starts. Cute. You just bypass some layers and then you start calling their internal modules and all that. And within a month or two, you have all this messy code base where you change in one place, it's going to blow up in 20 different places because you allow others to poke into your internals. You did not put barrier saying that if you want to talk to my module, you need to come to only through this public interface. You are not allowed to talk to my internal system. That kind of a tooling is not there earlier. Luckily, we have that sort of tooling now. So with this, you are a senior developer or you are a tech lead or architect, they don't need to continuously monitor each PR and then saying, no, you should not do that. So it is automated as a automated test, so that when you do some change, it's going to check automatic way, like, are you violating any of these architectural principles? Test is going to fail, build is going to fail, so that you don't need to have this manual verification all the times. So that's going to prevent. Okay, now how is this Spring Modulith is actually helping in that? So I hope most of you are familiar with Java and Spring Boot framework. Can I assume that? Okay, so let's say we are building a bookstore application, and this is how my typical code base looks like. And I'm following this package by feature packaging structure. There are usually packaged by layer and then packaged by feature. Usually it is highly recommended to follow package by feature, or you can also say package by module, where you put all one subsystem related things into one module, okay, one package. So here we have a bookstore application, and if you are familiar with Spring Boot, you also know that this bookstore application class is nothing but our main entry point class into the Spring Boot application. So this is what you run to start the Spring Boot application. So now Spring Modulith says all the packages in this bookstore package is called a root package, root module, And then all the direct sub packages are considered as modules. Okay, so here we have catalog module, common module, config module, inventory, notifications, order modules. So these are all the modules we have. So when we have the modules, there are certain rules that Spring Modulith follows, which is like in a catalog, as we discussed, catalog is considered as a module. So here inside the catalog package, we have product API, product DTO. Both are public classes, class or record, whatever, they are public. Okay. Only those two classes are accessible from any of the outside packages. They cannot access any code inside the domain mappers or web packages. All these packages and classes inside them are considered as private to the catalog module. Okay. So now, if you are building a module, only the public classes in the direct module root are considered as exposed interface. That means other modules can access only those classes. So you can say, okay, I can follow that pattern and only make the classes that I want to expose to other modules as public, and other things can I make it as a package private so that anybody cannot access from other packages. But your code may grow and you might want to put them in sub packages. Then if you put those classes in sub packages, you need to make them public again, right? So let's say I have some class in my domain package and I want to access it from my product API. I need to make that as a public class. Otherwise, I cannot access that from catalog package. But the problem is the moment you make it as a public class, anybody can call it. Java compiler doesn't prevent you from that, because that's a public class inside domain and anybody can call it. So this is where Spring Modulith comes into picture, because it imposes those rules saying that only this product API, product DTO can be accessed by other modules and rest of the packages are internal to that module. So that is one thing. And second thing is uh, circular dependencies. That is another problem. Like you start calling from catalog module to, let's say, inventory, and then inventory again call catalog. So if you start making these circular dependencies, that's going to cause a lot of problems, like again circular dependencies and then Spring Bean issues and all those things come into picture. So Spring Modulith again takes care of, it doesn't allow to have a circular dependency across modules. So you cannot have one class from catalog package depending on inventory and another class from inventory depending on catalog. It won't allow that. Okay. Let us see it in action now. Okay. So this is the code base. As I mentioned, we have the same structure here. These are the two classes. Is code visible? Okay. So these are the only two classes that are public. Okay. So anybody from other packages like orders or inventory or notifications, they can only use these two classes. They cannot access. So let's say I have in domain package, I have product service, which is a public one. Okay. But you cannot access when you are using Spring Modulith. So now how Spring Modulith ensures it is not letting you access other modules internals. Okay. So all you need to do is you need to write one test. Okay. So here you create application modules and you give the Spring Boot applications main entry point class, and you write this one little test that says module.verify. So what does it do? It verifies what are the rules Spring Modulith imposes. Is it being followed in this application or not? Okay. So now let's run it. So both tests passed, and which means we are following Spring Modulith properly. But let's try and break it. Okay. So here, as I mentioned, product service is a public one, but it is inside domain, which is supposed to be a private part of the catalog module. Now let me try to inject that from into this orders web, let's say, okay. So here, so this is one nice IntelliJ feature where if you want to inject any Spring Bean, you can start typing the bean name and it's going to automatically declare a final field of that type and automatically inject through the constructor. So you don't have to manually write all that. Okay. So here I just injected that. Okay. I don't even need to use it. Now let me rerun the modularity tests. So now the test failed and it is saying there is a violation. Module orders depends on non-exposed type product service. So compiler level wise, it is allowed. It's a public class, but Spring Modulith prevents that. You are not supposed to call internals of other modules. So the benefit of this one is you can have like microservice teams, right? Each microservice is maintained by a different team. You can have the same team structure even for modular monolith. One team can work on the catalog, another can work on orders. So like that, you can still work on, and each team can come to an agreement that, okay, this is my public API. These are the public classes. If you want to call, only you are allowed to call these APIs. So you have the luxury of doing what kind of a refactoring you want to do, everything. You can change whatever you want in this private part of it so that it won't affect anybody else. Okay. You are, as long as you keep this consistent, it's going to be working fine. Okay. So this is one thing. And another one, like let's say I talked about circular dependencies. It doesn't allow. So here we have.
My study is the modularity enforced using tests.
Yes.
There's nothing stopping from ignoring a test if it fails.
Yes. If you
You know,
you right, right. So this is, you are verifying this through a test, but if you don't write test, you're yeah, yeah, that problem is there. But if some developer is commenting out the test, you have a bigger problem.
if you card the fact, then also you inject your test like that or put it
Sorry, product.
address your card.
So in I have a controller here in orders package, and I am trying to inject a private part of catalog. So this product service I injected into this other module.
Can you use an existing project, but like after that, what we get a list of violations?
Yes,
Uh,
yes, I'll talk about in a minute. Yeah,
okay. So I think they say monolith default settings that the monolith.
exactly. You can use that. In fact, if you have an existing application which is not, of course, following all these guidelines, you can start and add these Spring Modulith dependencies and then make them as, let's say we have a common package and we are dumping all the utilities and common code here. And this can be used not only the exposed part, let's say I organized most of these utilities in sub packages also. I just want to enable anybody can access even the classes inside the sub packages. So what I can do, I can explicitly mark it as a application type of open type. So when I make this as a open type module, anybody can access not only the public parts, a public API, you can also access the classes inside the nested packages. Okay. So if you have an existing application and you want to move towards the Spring module, add the dependencies, make all of them as public open type modules, and then run the test and then verify, okay, this is how all the violations we have, and then start resolving all those one by one. So that is how you can progressively make it as a monolith.
Okay, there's a test dependency. Or does it also have a
You have both. The verification part comes as part of the test dependency, but these are like a core that is going to be packaged with your application. Yeah.
module? part of your product.
Right. So let's take a quick look at dependencies here. So if you look at, so here we have Spring Modulith starter core that comes with all these definitions. So yeah.
Well, that's not say that you want to expose that but that's a fact. What is enforcing that the calculus say that the is the time?
Yes.
Um,
Yes. So here in catalog module, nice. We don't have to expose anything else, and we just have this product API, product DTO public. That is sufficient for us. But let's say we have a advanced module like orders. So here we have some public API, and also we have some models like order created event or customer. And let's say notification module depends on order created event, and also the other customer order item and all these things. So now how can I make it available to other modules? So if I want to expose any classes inside the nested packages, what I can do, I can create this package info and then make it as a named interface. When you make this package with this package info.java and then use this named interface, you are automatically exposing this particular sub package to the other modules as well. So here only other modules can use the classes, again public classes inside these modules, but they cannot use mappers, they cannot use web anything inside the web. So you can selectively expose some of the code that you have inside the nested packages using these named interfaces. So especially you do this when you have all the models or some reusable things inside the sub packages, then you can expose that particular part.
when you say module, you need packages that get back into the Java.
So, okay, let me quickly.
Yeah.
So here in Spring Modulith world, so this is the root package. Bookstore is the root package where we have Spring Boot application main entry point class. Inside this bookstore, all the top level packages are considered as modules, like that. So like that, you can selectively expose some sub packages as to other modules. And another thing, like let's remove. Is there?
That's definitely.
1 second. So here you can give whatever the name you want, but it's logically you give, okay, this is inside the orders package and these are the models. So it's up to you how you want to name it. Okay, now let's check. Let's undo these changes. Okay. Now let's see what happens if we make a circular dependencies across modules. Okay. So in orders package, we have this domains, models, and we have order created event. And this is being used in inventory module. So inventory module depends on orders module. Now, if I try to make a circular dependency like in, let's say in order service, let's say I want to inject inventory service. Okay, so this inventory service is inside inventory package. Okay, now I make this bidirectional circular dependency. Now if I run this test, it's going to say that cycle detected. Inventory depends on orders, and then orders again depends on inventory. So you cannot have these cycles across modules.
So this is only across modules, not within the same package.
Within each module, you can have dependencies because it's your code, your module. So you can have packages.
So, that is a module.
So it is like Java access modifiers. If it is public, then only classes from other packages can see it. If I just make it as a like package protected, any classes from outside of this current package cannot even see it. So you cannot even inject it into anywhere. By default, a Spring Modulith follows this rule of, okay, this is the main entry point class, and then follow all this, consider all this as modules. So you don't need to configure anything. But if you want to have some customized configuration, okay, I don't want to treat config package as a module. So you can customize that by enabling auto detection turn off, and then you can say only if I add some annotation, consider this as a module. So you can customize that. So we talked about this open type module where if you want to expose everything, not just in the root module, but any classes inside the sub packages, you can make that as a open type module. As I mentioned, if you are transitioning from one monolith to Modulith, this is where you can start and then gradually resolve all these conflicts and everything.
So in this case, the test will run, but we get warning. So
Yes.
get rid of those events.
Exactly. So you can start somewhere and then identify, okay, you can. So the best way to transition from monolith to modular monolith is first to try to refactor your code from package by layer to package by modular feature. So that's already solves some of the issues. And then by running this monolith test, you can identify, okay, is there any, we are poking into the other internal modules, classes and all that.
So then factor that first, and then we should show all of them are open as part of our test so that we can actually identify.
Exactly. So the next thing is, let's say by default right now, I do not customize anything. That means a module can depend on any other module's public API. Like from orders, I can call catalog exposed API. I can call inventory exposed API. So there is no restriction. But if you want to be strict about it, like you want to precisely order modules only can depend on catalog, but not inventory, but not notifications, anything else, you can go ahead and use this explicitly mention allowed dependencies catalog only. Okay. So here, when you mention this, if you try to access any public API also, let's say in notification, there is a public class, you cannot access this because you are explicitly saying orders module explicitly depends on catalog only. You cannot access any other things. So if you want to be more strict about it, you can use this as well. Open modules, I think you can use, but all other exposed interfaces, those you cannot use.
Yeah, other than code making, are there any other benefits with
Yes.
it?
Not scalability. One of the thing when you are building a monolithic application, one of the reasons things get messy over the time is your code start coupling from one module to another module and all. So one of the suggestion is usually when some user of the application do some action, there will be a primary action that you need to take, and then there is a consequence. Okay. So it is always recommended to implement that direct effect as a synchronous operation. Okay, you click on some button and you are supposed to store that data into a database table. Once that is done, you want to trigger some other process. For example, let's take in a bookstore application, you are placing an order. Okay. So when you place an order, the primary action is take the details and store it into the database. That is the primary action, right? But once you store that, you need to trigger processing that order. Maybe that consequence, you can use events. Okay. Once you store that data, fire an event and let some other module consume that event and then proceed further. So in Spring Modulith, it is highly encouraged to minimize the direct dependencies on other modules. You are encouraged to only handle the primary action in your module. And then if you want to trigger this consequence action, use events, fire an event, and then let other modules continue processing it. So one of the challenge in achieving that is, one is like if you fire an event, either you need to go for like Kafka, RabbitMQ, whatever the messaging broker systems that you can use. But Spring Modulith also comes with eventing support, like let's say, okay, Spring Framework provides this application event publisher class, which you can use to publish events. So here we are simply saying, okay, when an order is successfully created, we created an order created event object, and then we are saying publish this event. By default, without Spring Modulith, how this works is you fired this event and then some other place there will be a listener to it. Let's go to this, not here. So there will be a listener. Let's say here in notifications, we have this event handler here. So it is completely disjointed. There is no direct correlation. However, in Spring by default, all this logic is going to be executed in one big transaction. So it's a kind of a problem, like your database transaction span across a long activity. So one option is you can use async processing, like you publish that event in a asynchronous fashion and your transaction ends right there. But the problem with that one is when the consumer consumes that event and if it fails, you lost the event. There is no persistence mechanism. If you consume that event and then it failed to process, it's gone. There is no way to recover that. So Spring Modulith comes with a feature where you don't need to go for Kafka or RabbitMQ and all that. Spring Modulith provides this event persistence mechanism where when you publish this event like this, you can enable this event serialization mechanism in such a way that when you publish it, first it's going to store that JSON, whatever the event you filed, right? It converts into JSON and then first write it into a database table. And there can be n number of listeners to that event. And each listener is supposed to consume that and process it. Once it's successfully processed, then you can mark it as, okay, this is successfully processed, or you can even configure it to delete that one. Okay, so this way you don't actually need Kafka or any other external one. Within your code base, you can have successfully implement this. Usually this is called outbox pattern, right? Where if you have some database related activity and then you also need to process events, so you need to persist that so that you can retry any number of times. So that pattern you can simply follow here without relying on Kafka, RabbitMQ kind of a thing. Sorry. So this is asynchronous. So here what happens is when I say publish event, this is going to store the data, order data into the database. And this event is going to be stored in another events publication table. And that comes as a transaction. That's end there. And then this event listener is going to consume that. And let's say this is successfully processed it. And then it's going to update that it is successfully processed. Or you can configure it to delete that processed record. So usually who publishes it, they own the event, but you can also move that into a separate package and then let this, it is up to us, but the Spring Modulith author recommends whoever publishes the event, they should own that.
So can a different module have access to this?
So here that event is there inside the module, and I have made that as a named interface so that others can access it. Okay. And in addition to that, there is another feature where, okay, within the system, you can raise the event and then publish the event and somebody consumes it, process it. But you may also have other applications in your organization where they are interested to consume this event and process it. In that case, you may also have like Kafka, RabbitMQ, which other applications might be listening to and then interested in. So again, Spring Modulith provides this eventing support where I have configured my RabbitMQ and I configured this is the exchange and this is the queue name. And when I say simply here, I mentioned publish this event, it not only publish the event and then let persist in the table, it also sends that to RabbitMQ. Okay, so here it also published that event to RabbitMQ. So it depends on your use case. Like if you don't want to have all the heavy machinery of running RabbitMQ or Kafka and all, if you are running only your application, you don't need that. Huh. Yeah. So then you don't need to use this. You can only focus on publish that and then consume it. Let's say from the maintenance point of view, one less thing to worry about. If you're architect, then think about, okay, I already have a mechanism where I do not lose the data. Okay. So one less thing to worry about. But if it is already there where you are talking to multiple applications are using it, then you don't need this internal eventing mechanism. You can still use Kafka or RabbitMQ, whatever. Uh, it's practically a table. So so here I have connected, here there is event publication. Let me, so here you can see when I publish a order created event, so this is the type and it also keep track of who are all the listeners are there. So here you can see there is one listener in inventory module, order event inventory handle, and there is another event handler in orders module, notifications module. So it keeps track of what are all the listeners are there. So when you publish one event, it's going to serialize that event like this in a JSON format. And once it is successfully processed, it's going to, let's see, it's going to update. If it is successfully processed, it's going to update when this got published, processed successfully. By default, it's going to have null. And if the listener consumed it, processed it, it updated this, saying this is completed. But eh, you can customize that. By default, it is all asynchronous. There is no serial processing, but Spring Module exposes these interfaces where you can customize the behavior. So all the events information is captured here, and then you can customize, okay, I want to process in a serialized, whatever the serial based manner. So you can customize that as well. So the problem with in-memory is, let's say you published an event successfully, and then before the listener process, if out of memory, whatever issue, if the application dies, that is lost. This is database. I connected to this PostgreSQL, and when I say publish event here, it's going to write that event, convert that object into JSON, and then store it into this database. So it is going to be permanent. Okay. So here, let's assume you published event successfully and then application died for whatever reason. So now you can configure in such a way that republish outstanding events on restart. So once the application restarted, whatever all the pending events are there in the table, they are going to publish it again, and then your listeners are going to process them.
You have to add it.
You have to manage? Yes, yes. If that is what you customized, you have to take care of that. And also here there is completion mode. By default, it is update, which means the process time is going to update. But if you want to delete them, you can delete. You can configure this to delete. So one listener completed processing an event, it's going to delete that row. So next, let us take a look at how we can generate documentation. So as I mentioned, you follow certain structure and it's going to reflect what your application module structure looks like. So here, now when I run this test, it's going to simply generate this documentation. You can generate different styles of documentation, C4 diagrams or plant UML, whatever. There are some multiple options available. So here, when you run that, it's going to generate Spring Modulith docs. And here, if you open it, so here you can see it automatically generated this diagram that says, okay, here notification and inventory modules listens events published from the orders module. And again, order modules uses catalog module. So it automatically inspect all the interactions between the module, and then it will generate the diagram so that you don't have to create it manually, and then few months later it all got mismatched like what you have. And obviously nobody updates Jira or Confluence documents, right? Do you update? I don't.
Very good. So can I use this example writing feature in microservices, like the new projects which we are implementing?
Yes. So though we are saying monolith, the rules applies to microservice also. Let's say in your microservice, you are taking care of two things, and still you can apply the modularity concept there also. So you can use this feature and then generate the diagrams. So another nice feature, like we all know in microservices world, we need to have this monitoring support where, okay, here it started the process and then it called another microservice and then it published an event. And so you need to have this traceability and all that, right? So here, even in single monolithic application, you can have the traceability where it says, okay, I started my process, like I submitted a new order and then it talked to Postgres database, saved some data, and then published an event, and notification service consumed it, inventory service consumed it. So you can have the traceability. Let's run the application. Let me see. Okay, application is running, and so here service name, as I mentioned already, it identified different modules as service names, though they are just modules. In Zipkin, it represents as a service. So here, let's say orders, and I want to see all this. Okay. Right. So here, okay, let me publish an event. So here I'm going to place an order, a couple of orders. Okay. So now it should. Some issue. This demos sometimes doesn't work.
Now, later that being still here as well. to do our sending a package to teams.
Sending package to yes. Yeah, see, I think I wrote James Bond or something and then deleted it.
Hey, you won't give me copyright violation.
So here, our process started with orders model. We placed an order, and then it involved all these modules while processing this request. So we stored the data in Postgres table, and then we published an event, which also while placing the order, we talked to catalog to verify the price and then getting the product details. And also we published an event. That event is consumed by notification service and inventory module. So it shows all that, even though in one application, just like how you have this traceability and everything in a microservice setting, you can have the same thing even in a single monolithic application as well. Okay. So let me see, is there anything else I miss?
This is now for modular.
Yes, Spring Modulith. Basically, it is bringing the disciplines to the teams. Like I was mentioning, when you are working in a deadline-driven environment, you start skipping some rules and then let's fix it in the next one. Or some new person join the team and may not know all the decisions that are taken in the beginning of the project, so they may violate unknowingly. So having a senior or architect every time looking at the each PR and then commenting out, that's not practical. That's one of the reason we got monoliths that are big ball of muds. So these rules automatically ensure that each module is living in a proper shape, so that over the time it doesn't become like a big ball of mud, and each module can, I mean, one of the best part is most of the times when you start a project, you don't know exactly where to split the microservices and all. So you can start with monolith, build each module as independently as possible. And let's say tomorrow you see, okay, people are doing window shopping, they are not actually placing orders. And for window shopping customers, I need to run 10 instances of catalog. Okay, let me extract that as a separate microservice, spin up 20 instances, but then keep the rest of the application for 5 instances. So that extraction process makes very easy when you are following the strict rules, because you are explicitly saying, okay, this is the interface I'm exposing to other modules. You are not breaking anything by removing or moving any of this logic into a separate service. So sorry, it's going to be a single Docker image. I mean, it's not going to be multiple jars or anything like that. It's still one single Spring Boot application.
So how do you compare this to Arcubate? Like Arcubate is basically only the test part of it, like imposing constraints, but it does not have the observability and the other.
So in fact, Spring Modulith depends on Arch unit. Internally, Spring Modulith uses Arch unit, and then make sure, yeah, exactly, yeah. How many of you are using Arch unit? Wonderful. So if you want to put some discipline into the team, this is where you should start. Okay. So this is where you can restrict automated tests, saying that, okay, you need to follow these guidelines. You need to structure your code in certain manner. So it's a fantastic library, and you should definitely take a look at it, where you can specify all kinds of rules like, okay, no controller should directly talk to repository. It should only go through service. You can expose that as a JUnit test. Like that, you can write whatever rules that you follow, you can express them through Arch Unit. So the Spring module is built on top of it so that it can impose all those rules. Like, okay, you cannot have circular dependencies, you cannot poke internals of the other. So internally that uses Arch Unit. Any?
We have to scale the whole application.
Yes. So though it is a modular monolith, it's still a monolith. That means you need to run all the application again once.
So it's actually the good starting point after which you can make better decisions based upon whatever metrics it's like.
Exactly. Most of the times when we are starting, we have least amount of knowledge of where is the boundaries. You assume that I know DDD and I know bounded context and all that. And then you go aggressively and then split everything into 10,000 microservices and then you cry. Okay. So this is where you be disciplined, build application, and then over the time you see the pattern like, okay, this is really a separate thing and you can extract it. But if you either be aggressive and then split 10 things into 100 things, and then you spend a few years and months merging them back. And we did actually, practically we did that in one of our application. We separated promotions, we separated products, and then somewhere we need to show based on the consolidated price. For that, we need to get all the data because in sorting, you need to calculate the effective price based on the current price and then promotions and all that we maintained in different services. But when you have pagination, you need to calculate that. So we did overaction and then corrected merging those services.
What are some of the main challenges you face when you actually start off with the modular thing based on to stack microservice out?
Very good question. Like I thought of miss. So here, as you see, Spring Modulith is taking care of all the code and then modularity and everything. Okay. But then if you have your database all as one database itself, and from different modules, you talk to all kinds of tables. So though at the code base level, you have this modularity and each module is talking to all tables. So you have that, it's like having microservices, but having a one big monolith in the front end, right? So it's like, uh, that is why we need to follow this strict separation of, we have separate schemas so that each module can store respective data in a different schemas. So catalog, all the catalog related products information goes into catalog, all the others goes into this one. So this is not a strict but highly recommended, because if you don't follow this and then some order repository is talking directly to catalog tables, then later if you want to extract that as a separate microservice, you cannot do it simply because you have tangled all at the database level. So it is important to separate the schema so that only catalog is talking to the catalog tables. And if you need any information, you should go through the module invocation. Okay.
Do we have checks for this?
No, I think it's no.
It is a database that looks like it's separated for something we just join this. But then there is also a challenge if we create views or
Huh.
from application team forming a team of each,
Yeah,
which again leads to a big class later on.
right. So here the arrangement is like when you want to go in the direction of modular monolith, though you are all working in the same application, same code base, think of it's as a separate microservice, which means this package is owned by the other team, this schema is owned by other team. You are not supposed to mess with it. So think in that sense, like this is a separate microservice.
Yeah, slowly.
Yes. So if you want to talk, only talk to this. don't talk to any of the internals, and you cannot. Spring Modulith prevents that.
So the entry communication, is it still HTTP or is it just like a regular Java?
It's a regular Java code method calls. So that is another benefit. Like until it becomes necessary, you can avoid that network call, make it as a direct Java method call. So when the time comes, you make it as a separate service, then it will become HTTP call.
So how do you change the comment? So it is the public shares like when you get started, how would you?
So good point. Like here, I have a web controller that is depending on product API. So right now I'm injecting this direct Java service, right? So imagine we are extracting this catalog into a separate microservice. So what is going to happen is you can still keep this package and just change this implementation to call that microservice. So yeah, instead of a method call here, you will write code to make a call to microservice. And also there is one feature where if you want to, I already mentioned how you can express only dependencies that you want to explicitly mention. If you don't mention it, you can call anything directly. But if you want to depend on another named interface, you can follow, let's say in catalog, there is some sub package called models, and you want to expose all the classes in that model. You can write something like this.
So one follow-up question is, oftentimes you will notice that even within the specific extracted microservice, I may want to create nanocells, CQRS.
And
Is there anything that helps locate that?
yes. So here again, if it is already a microservice and then you want to have CQRS where you write and then you read, you can consider them as two separate modules for the separation, and then you write all that in a write module and then read all from that. So in fact, Oliver Spring Modulith key author recently published an article on the exact same thing, like Spring Modulith CQRS. So it's a good reference point. So basically you treat your application, be it as a monolith or microservice, treat them as separate modules, and you can implement CQRS based on that concept. So here earlier we have placed some orders, right? So if we go and check here, we place 6 orders. In addition to getting that data into our tables and then processing by inventory and all that, we also published 6 order created events here. So you can get. So here you can see order details are published to RabbitMQ also. If there are other applications who are which are interested in consuming this, they can also process this. Exactly. So here I have the configuration, RabbitMQ configuration. So here I have RabbitMQ Exchange, bookstore Exchange, and I have routing key, orders new, and all that. So when I simply configured this externalized bookstore exchange orders new, Spring Modulith is going to automatically figure out, okay, this is the exchange and this is the routing key I need to use, and then publish that event. So we don't need to write any code separately. When you simply publish through application publisher, it's going to take care of all that. Yes. Instead of RabbitMQ, you can use Kafka, and this would become, what is the similar? Yeah, topic. And I'm not familiar with Kafka, but I know there is something compared to that. I'm not aware of that dynamically changing. No. There is support. There is support. This is kind of a static. You define, okay, this is where you need to send this event. But you can dynamically configure that through programmatic method. You can write a method, and then that is going to be called with this event data. Then you can dynamically write whatever code, like, okay, you want to send it to Kafka or RabbitMQ or both. You can do that dynamically. Okay, thank you.